In this video, we're going to be talking about how we break up those individual energy shells into smaller and smaller components. And then the video after this, we'll be discussing how electrons will fill into all of these little small regions of energy shells. One thing to keep in mind for this is that everything I'm going to cover in this video is based on something called quantum mechanics. We are not going over quantum mechanics in any detail whatsoever. So what you need to do is just take what I'm saying as fact, because I don't want to get into the really high-end math required to understand how all of this works. Okay, you are going to need something to write with and something to write on. This video is actually going to be on the shorter side. So once you are ready, let's go. Okay, so in quantum mechanics, what they basically did was they took Bohr's model of the atom and they applied the fact that we don't know exactly where the electrons are. It's called the Heisenberg uncertainty principle. And we also did some statistics to this so that we could map out where an electron is likely to be based on the energy shell that it's in. All that said, what that means for our practical purpose is that we can divide the energy shells, 1, 2, 3, 4, those different rings, into smaller and smaller pieces where we're going to find electrons. Okay, the first thing that we have is we have what's called a subshell. Each energy shell can be divided into a number of different subshells. These subshells are called S, P, D, and F. That's just how we label them. Now, each subshell has its own characteristic shape. I'm not going to get into shapes with you guys. That's something that I'll save more for the advanced placement class. But what you need to know is that the subshells that an energy level can have depend on how big the energy shell is. The bigger the energy shell, the more subshells you can split it into. Right, so the first energy shell, the one closest to the nucleus, is really tiny. It's so small it's only allowed one subshell, which is what we call the S subshell. The second energy shell, a little bit bigger. We can split it up into the S and the P. Third energy shell, a little bit bigger. We get the S, the P, and the D. And then the fourth energy shell is bigger than that. We have the S, the P, the D, and the F. Once we hit element number 120, or sorry, not 120, number 121, we will then get to a higher energy shell, most likely, that we're going to call the G shell. But we haven't gotten there yet, so we're not sure if it actually exists. Okay, so energy shells can be broken up into subshells. The bigger the shell is, meaning the farther away it is from the nucleus, the more subshells you can break it up into. Now, we can also take these subshells and break them up further into regions that we call orbitals. Orbitals are just regions where there's a very high probability of finding an electron. Like I said, what we did was we took Bohr's model and we did some statistical calculations with it, and we were able to figure out in 3 dimensions at any given point from the nucleus, how likely is it that you'll find an electron there. Regions where you have like a very high probability, we say better than 90%, are what we call orbitals. This is not to be confused with an orbit. Okay, this is not like Rutherford's model where electrons orbit around the nucleus. Here, an orbital is just what we call a location where an electron is probably going to be. And the larger the subshell is, the more orbitals it's allowed. Right, so S subshells, because the first energy shell only has S has to be pretty tiny. S subshells only get 1 orbital. P subshells, they get 3 orbitals. D's get 5, and F's get 7. Now, the thing to keep in mind is that each of these individual orbitals can hold 2 electrons. Right, so the S subshell can hold 1 orbital, which is 2 electrons. The p subshell has 3 orbitals, which is 6 electrons. Right? So first energy shell only has S. S has 1 orbital, which means 2 electrons. So first energy shell is 2. Second energy shell has S, which can hold 2, P, which can hold 6. There's our total of 8. Third energy shell, 2 plus 8 plus 10 is 18. So this is where we get 2, 8, 18 from, is this breakdown. Okay, so shells can be broken up into subshells. Subshells can be broken up into orbitals. Now, as far as the electrons in an orbital are concerned, there's one other thing we care about, and that is that electrons in an orbital have a property that we call spin. They don't actually spin, but spin is a result of their magnetic field, so we call it that. Now, whenever you have 2 electrons in the same orbital, they have to spin in opposing directions. They can either spin up or down. Basically, any opposing directions will work. We use up and down. If you want to use clockwise and counterclockwise, that's also fine. Okay, so these electrons that we're trying to locate, they exist in energy shells. Those energy shells can be broken up into subshells. Those subshells can be broken up into orbitals, and every electron in an orbital has its own spin value. So if you can kind of see how we're starting to organize these things, what we're going to be doing in the next video is we're going to go over an address system that will help us locate where electrons are.